lesson is on negative exponents and zero. Well, we've already talked about having zero as an exponent, didn't we? What?
Yeah. Just switch to one, right? Put something with an exponent of 0.
Then it's always 1. There we go. You probably didn't hear this question that just came about that said, what do we have if we have an exponent of 0? It's always 1, right? We talked about that. Okay. All right, so we're going to do a little review here before we move into the new stuff. All right, x to the 8th times x to the 2nd power. Remember, when we have the same base, the base is x, and we're multiplying, what do we do with the exponents? We add them together. So 8 plus 2 would give me x to the 10th power. Very good. All right, on number 2, before we add our exponents, what do we have to do first? Right, very good. We have to multiply the 5 and the 2, which would give us 10. Then we put our base of x, and what's the exponent? 6. Very good. Okay, number 3, now we're moving into a little reminder about dividing with exponents. Our base is the same. We have an x in the numerator and x in the denominator. So therefore, we do what with our exponents? Subtract our exponents. Now, we do have to look to see where the larger exponent is, right? Which in this case is in the numerator. So it's just going to be x. Oh, it's just going to be x, right? Because 3 minus 2 is 1. And we don't have to put the 1 for the exponent. Okay, and number 4, the first thing we need to do is simplify our coefficients. So 4 over 8 would simplify to 1 over 2. 1/2 or 1 over 2, good. Then we have x to the 3rd power in the numerator and x to the 1st power in the denominator. So where does the x go? In the numerator, very good. 3 minus 1 is 2. And then the y's, where's the larger y exponent? The bottom, and 3 minus 2 is just 1. That would look a lot better, though, if we just wrote x squared over 2y. We don't need the 1 in front. We know if there's not a coefficient shown that it's 1, and then if there's not an exponent shown that it's 1. We know that, those two things, okay? All right, so that's a little bit of a review. Here's a little bit more, going back to the powers that we learned about previously when we have to raise a power to another power. But first, remember, we have to do 6 to the 3rd power. 6 times 6 is 36 times 6 again. 216? 216?
Yeah.
We sure?
Yeah.
Okay. Maybe. Well, maybe you should check your peers.
Yeah, it's 216.
Okay, thank you. All right, and then we do x to the 4th power cubed, which means we write x to the 12th power. You multiply the powers. Very good. All right, number 6. We have to take care of the numerator here first. So 3 squared is 9. X cubed squared is
X to the 6th
okay, good.
power.
X to the 6th power, and then y
To the second, or like
to the 2nd power. Because if you don't see a power, it's 1, and 1 times 2 would be 2. All right, and then go ahead and carry over the 24 x to the 4th power, y squared. All right, start with the coefficients. 9 over 24 can simplify.
3 over 8.
Good. 3/8. Where will the x go?
On the top.
So x to the 2nd power. And what about the y's?
Cancels out.
They just cancel. Okay, so there's your answer. Very good. Okay, that's everything we've been working on from the previous 2 days of exponents. All right, now, and we have discussed this right here. Now, these are not negative exponents. These are problems where the base is a negative number, and reminding ourselves when the negative is in parentheses versus when it's not in parentheses. Okay, so remember here with this first one, negative 3 to the 4th power is good. Negative 3 times negative 3 times negative 3 times negative 3. Okay, which every time there's a pair of negatives, it makes a positive, doesn't it? So it's really just 9 times 9, which is 81. Do you guys see that?
Yeah.
Okay, versus the difference here is a negative 3 times 3 times 3 times 3, right? So therefore that one would be
Negative 81.
negative 81. Good. Are you trying to make sure we can hear you on video? Yep. Okay. Thank you. Okay. All right. Number 8. Negative 6 squared, and because the negative's in parentheses, it's going to be negative 6 times negative 6, which is 36. Versus a negative 6 squared, which would be negative. Good. Okay. How number 9? Negative 10 in parentheses squared.
Or negative 36.
Whoa.
Oh, sorry, I was still on the last one.
100.
Okay, you're going to have to bring it down. Okay, thank you for raising your hand. Yes.
I noticed how all of the exponents are even, so what if it's odd?
Okay, if it's an odd exponent right here and we have the negative inside, then it's going to end up being a negative answer because you're going to have that extra negative. That's a good observation. Okay, so just because the negative's in parentheses doesn't mean the answer is always positive. Do you see that? Okay, because if that was a cube there, negative 6 times negative 6 times another negative 6, there'd be an odd amount of negatives resulting in a negative as your answer. Okay, but here this is always going to be negative because it's negative and then you just square the base. Okay, all right, so down here, negative 10 in parentheses squared because there's just two negatives. It's going to be a positive 100, and then this one's going to be negative 100.
So if you have parentheses around a positive number and it is an odd number, it's negative?
No, if this was a positive number, it's just going to be positive. Yeah. Okay, so what do you think 2 to the negative second power would be? Do you feel like this right now?
Yes.
Oh my gosh, I just got hit in the head with a negative exponent. Yes, in the back, loud.
1/4.
Why do you suppose that?
Because if it was a negative, that means it wouldn't be a whole number. So then it would be 4 because it would be 2 times 2, which would equal 4/1. Is he right?
Okay, he is right.
Yeah.
Okay.
Always right.
So this would be, it would be 1/2 squared, which is 1/4. Okay. Now, if you're a little like, I'm not sure, it's okay. I'm going to explain this so that this will kind of, you'll get the hang of this. So number 10, what about 3 to the negative second power? We would rewrite that as 1/3 squared, which is not 6 because 3 squared doesn't mean 3 times 2. 3 times 3, so 1/9. Very good. How about number 11? Raise your hand. Oh, do you have a question about that one?
Yeah.
Sure.
I forgot it. Never mind. I'll think of it later.
Okay.
I forgot it.
I'm one puzzle.
Okay, number 11. 5 to the negative 1 power. Ethan?
1/5.
1/5, because it'd be 1/5 to the first power, which is just 1/5. Okay, number 12 here. We've got negative 2 raised to the negative 3 power. Okay, let's just rewrite this like this for right now. Write 1/, put your negative 2 in parentheses, and then all that does is it makes my power become positive, right, by moving it to the denominator. And then you can deal with what that actually is right there, which would be what?
1/8.
Good, 1/8, because a negative 2 times a negative 2 times a negative 2 would be a negative 8. Good. All right, what do you think about 13? Who has an idea about 13? Chase?
Oh, you're going to flip it.
You're going to flip it because this power is really here and here. And so if in order to make that power positive, I have to move this down here and give me 2 to the first power, or just 2. I have to do the same thing and get 3 to the first power, or just 3.
I don't get how you did that. You just
Flip
flip it.
it.
Well, but you have to explain why. See how in order to make this negative power become a positive power, we moved it to the denominator?
Oh.
Because this really looks like that, right? Okay, so we had to move it to the denominator. So if you're going to make a power positive by moving the base with the exponent to the denominator, then if the denominator has a negative exponent, you can make it a positive exponent by moving it to the top. And this is where my little funny explanation comes in. Okay, so you think of these exponents with the negatives as having a negative attitude, right? And they live in this little house, okay? They live in this little house, okay? And it's a 2-story house. And if they have a bad attitude and they live upstairs, we can make them have a positive attitude by moving to the downstairs level. Maybe they just rather live downstairs. And if they're downstairs and they have a negative attitude, we can make them happy by moving them upstairs. Maybe they just need a change of location. So you change the negative attitude to a positive attitude, or the negative exponent to a positive exponent, by moving floors. So if they're downstairs, move them upstairs. If they're upstairs, move them downstairs. And really that will make sense as we go a little bit further into some more difficult ones. I know it's goofy, but it helps. Colin.
What if the top one's negative and the bottom one's positive?
Then, hey, so if the numerator has a negative exponent, he's got to move downstairs. But Colin says, but what if there's somebody already downstairs and he's happy? Well, guess what? They just get to share the bottom level. Okay? He doesn't move. You don't move them just to move them. You're only going to relocate them if they have a negative attitude, if they have a negative exponent. Okay? So this one right here, and because this is a fraction, this goes with the 2 and it goes with the 3. So you need to move the 2 downstairs so it has a positive squared, and the 3 upstairs so it has a positive square for an exponent, which would then give you what? 9/4. Very good.
Yay.
Okay? So we got the idea of the house and the 2-story house, right? If it were only that simple in life, right? If someone has a bad attitude, you just say, hey, you want to move downstairs? You want to swap levels?
Or live in the basement.
Okay, so we got to make the exponent happy. Dun, dun, dun. It makes sense, right? A negative attitude, a negative exponent. Okay, I know. It's goofy, but. All right, so if you do not have a fraction, we know that you can always put something over 1, right? You know that. 5 is the same as 5/1. 7 is the same as 7/1. So x to the negative second power is the same as x to the negative second power over 1. So guess what? That x, he's not real happy, is he? He doesn't like living upstairs. So we're going to move him downstairs so that he can have a positive exponent. Now there's nothing upstairs, but we know from basic math that if we have to have something in the denominator, that we really can put a 1 in the numerator.
Wait, so no matter what, if it's negative on the top, you just move it down and it will turn positive?
Exactly. Okay.
Now, who came up with this idea?
This little
Because this is
explanation,
No, I'm talking about just move downstairs and
that,
Yeah!
oh,
it's like
that's just a simple way of explaining the rules.
Yeah, but
What's
why,
the rule?
why is the rule like that?
Why is the rule like that?
It's
math.
kind of just like weird.
No, but there's usually
Okay, I will be glad to explain. Would you like to listen?
Yes.
Okay. All right. So, let me get a blank flip chart here. Okay. All right. So, here's why. I'm picking this number out of the blue. Okay. I'm gonna just say 5. Okay. I'm gonna use 5 as my base. So we know that 5 to the first power is 5, right? We know that 5 to the second power is 25. We know that 5 to the third power is 125. Okay. We know that, notice the exponent, 3, 2, 1, 0. We know that 5 to the 0 power is 1. Okay. So then 5 to the negative first power has to be less than 1. It has to be a fraction. And so that's how we are making it become less than 1. Otherwise, it wouldn't be less than 1. Yes?
But wouldn't it be -5 then?
No, because you're not changing the base. This is the base. You're not changing the base. Okay? It's just a portion of the 5.
But like
And-
if you put, I'm sorry,
It's okay.
if you put -5/1, it would have been, I guess, unhappy. And then
This is a positive 5, though. You can't just decide to make that a negative 5.
like 5 to the first power equals 5, and 5 to the 0 equals 1, and then 5 to the negative first equals -5.
Okay, but these are all going to be positive values because this is a positive 5. So we don't want this to go into negative values because this isn't a negative number here that we're doing.
Oh, so if that base is a negative number, then your answer is going to be negative, right?
Yes. Yes.
But I don't understand. If you can do 5 to the second power, and you can write out 5 times 5, why can't you write
This isn't a -5. That's why you can't write out -5 times something. You can't change your base. You can't change that to be a negative. Okay? I think you just might need to mull over that a little bit. Just let that sit for a little. I mean, the same pattern would then continue here. You would just keep, you'd still have 5 squared, but it would be in the denominator, so it'd be 1/25. Yes.
So basically you solve it and then put a fraction bar and then a 1 above it?
Yes, but this is why.
Okay.
This is why, right here.
So that's easy.
Okay, look here. Let me show you something else. Okay, watch this. Divide by 5. You get 25, right? This is going to make sense. Divide by 5. You get 5. Divide by 5. You get 1. Divide by 5 and you get 1/5. Ta-da! Now do you understand? And divide by 5 again and you get 1/25. So there's a pattern there. So maybe I should have said that earlier. So
You got so excited.
well,
Miss Wilson,
Miss
sorry.
Wilson, I got one question.
okay, lunchtime. I have to keep going or we will not finish our lesson. I will be more than happy to entertain your questions at lunch. We will not finish if we do not continue. Please, come in. You can spend 45 minutes with me at lunch. Okay, so on 16, is the base that has an X, is he happy? No. So he's going to come to the denominator, and he's still going to have a power of 6, but it's going to be a positive 6 now because he's got an attitude change now that he got to move downstairs, right? Okay, look at the y to the third -3 power. He's not happy down there, so we're going to move him up here. And then now he's happy. Perfect. Okay, number 17. All right, so what do we do with this one?
You flip it.
Don't say flip.
Oh, well, you move that.
You move it downstairs.
He has to move down here so that we have x to the +4th power,
And you put
and
a
then it is 1 over. And I just showed you why on the previous flip chart. Okay, now this is really important you pay attention right here. This is 5 times x to the -4. So please do not think that that 5 goes with the -4 and that you're going to move the whole thing. Okay? The 5 is perfectly content right where he is. He's fine right there. The x to the -4th wants to move down here so that we get x to the +4th power.
Well, doesn't the x go with 5?
No, that's 5 times x to the -4.
Go ahead.
Okay? All right. Number 19. Same thing here, actually, really. See how that's multiplication there? So just because we're going to move this doesn't mean we move this. So it's the same thing with a coefficient. Okay, the multiplication separates the terms. All right, so anything going to say up here?
the y over seven.
Good. Y to the 7, and then in the denominator, x to the 5th. Very good. Okay, over here,
So when you add them together,
add what together?
because you're multiplying the.
They're not the same base.
Oh, yeah.
Oh,
They have to be the same base to apply the rules.
this makes sense.
Okay, so this is 3 times x to the -2 power. The 3 is perfectly fine because what does the 3 have for an exponent? A +1. So he's fine. So you leave him right where he is. Okay, the x to the -2 power needs to move downstairs, so it's +2 for the power, and the y is fine right where he's at.
Wow, that's awesome.
Okay, 21. Who's unhappy here?
Both
Both of them. So they both come down here, and then you have, it's 1 over that. Okay? All right. Here. The 2 is not happy, so we're going to move the 2 down here so that it has a positive exponent of 3. The x squared
Is
is happy. He's fine. The z to the -7 is not happy, so he comes down here and becomes z to the +7. But I would suggest that you simplify that a little further. Leave the x squared alone. 2 cubed is really what? 8, and then you have z to the 7th power. These are our last two?
Yeah.
Okay, so on 23, also, even though the 8 is fine because it has a positive one and the 2 is fine because it's a positive one, you can still do what with those? Simplify them down to 4 over 1, or just 4. And then the C, what are we going to need to do with that?
Bring it up.
Bring it up here. So really it looks like this, but you don't have to have a 1 in the denominator. We know that anything over 1 is just that original number. Okay, what needs to move in number 24?
The T.
Yeah, the T.
Just the T.
That's
But-
the numerator.
And it's going to have a Q. What about the 5?
It stays there.
It stays there.
But
Okay.
can you simplify?
7 over 5 doesn't simplify. Okay, sit tight for a minute, please. That is 5-3, correct?